Hello students, in this particular session we will discuss some derivation of results from hyperbola. If we consider the topics from conic section, out of them hyperbola is one from where we can get the difficult most questions, but it is equally true that if we analyze last few years paper and the tendency of questions to focus over particular concept, we have got certain questions which are very much result specific, and that results are mostly associated with this hyperbola idea. So we will go on deriving those results which can be very useful to remember as one-liner, and you can solve questions within few seconds using these results. The first of the result that we are supposed to derive, we will establish that for any hyperbola, a tangent taken in general that construct a triangle of constant area with the asymptotes of the hyperbola. Moreover, the point of tangency of the general tangent that appears as the midpoint of the side of that triangle formed with the pair of asymptotes of the hyperbola. So, I am having a diagram corresponding to that. Let us say this is one of the branch of the hyperbola, and if we mark the asymptotes, so these are the asymptotes. Though it is not required, but still I have shown the transverse axis of the hyperbola. Now, if we consider the hyperbola in standard form, it will be easier to derive the result, and once we derive the result, it will be applicable for all the hyperbolas, because once we get something associated with measurement, shifting or rotating the diagram in the two-dimensional plane will not affect the physical measurements found. So, keeping that in mind, we are going for the standard hyperbola x square by a square minus y square by b square is equals to 1. And on the hyperbola, if we consider a general point P with coordinate a sec theta, b tan theta. As you know, theta is the parametric angle that is also called the eccentric angle of the point P. Now, if we draw a tangent to the curve through the point P, say this is meeting the asymptotes at the point Q and R. And as we have considered the hyperbola to be the standard one, the center is at origin. So, we need to establish that the area OQR formed by this tangent along with the pair of asymptotes will be of constant area. Now, for the hyperbola x square by a square minus y square by b square is equals to 1, the pair of asymptotes are x square by a square minus y square by b square is equals to 0. That means, one of the asymptote is x by a minus y by b is equals to 0, and the other one is x by a plus y by b is equals to 0. So, the equation of tangent from the point P that can be found using T transformation on the hyperbolic equation. So, if I mark the hyperbolic equation H, x square by a square minus y square by b square is equals to 1, the transformation in the tangential direction using coordinates of P, we will get tangent through P as x into a sec theta by a square minus y into b tan theta by b square is equals to 1. As you can recall, the T transformation replacing x square with x x1 and replacing y square with y y1. Here x1 comma y1 is the considered coordinate. Over here x1 is the a sec theta and y1 is b tan theta, that is respectively abscissa and ordinate of the point P. So, this is our tangential equation. If we simplify a bit, it is x by a cos theta minus y by b cot theta is equals to 1. Now, if we try to have, let us mark this equation as capital T. So, we are now solving it with the asymptote x by a minus y by b is equals to 0. Let us mark them as asymptote 1 and asymptote 2. So, solving T and asymptote 1 says y is equals to bx by a. So, we can replace the y with bx by a from asymptote 1. So, that substitution gives us x by a cos theta minus bx by a by b cot theta is equals to 1. That is x by a cos theta minus x by a cot theta is equals to 1, or we can make it taking x common, it's sec theta minus tan theta is equals to a. We have multiplied this a to the whole equation, and reciprocal of cos theta is sec theta been taken into numerator, reciprocal of cot theta as tan theta taken into numerator. Sec theta minus tan theta and sec theta plus tan theta are two reciprocal factors. To generate the identity, sec square theta minus tan square theta is equals to 1. So, this gives us x is equals to a into sec theta plus tan theta appearing as the reciprocal factor of the other side factor sec theta minus tan theta. As soon as we get x as a sec theta, a into sec theta plus tan theta, we can have corresponding y as b by a times of this x. So, it will be b into sec theta plus tan theta. So, this completes the coordinate of the point Q because we have solved tangent with asymptote 1. So, now coordinate of Q we have confirmed as a into sec theta plus tan theta comma b into sec theta plus tan theta. On a similar note, if we target R like solving equation of tangent and asymptote 2, this time value of y will appear as minus bx by a. So, from the equation of tangent, if we substitute y is equals to minus bx by a, we are supposed to get x by a cos theta minus plus bx by a by b cot theta is equals to 1. That is x is equals to a into sec theta minus tan theta. I have jumped certain state. I think you can follow by the reference of earlier calculation, like the cancellation of b, then multiplication by a, and finally the sec theta plus tan theta that can be found as other factor 2x on left hand side, the multiplication of reciprocal factor to both sides. and if x is a into sec theta minus tan theta, the corresponding y part is minus b by a times of that. So, we will have b into tan theta minus sec theta as the ordinate, and these are respectively abscissa and ordinate for the point R. So, now we are done with coordinate of Q and R. The other vertex of the triangle was origin. So, if we go for area of the triangle OQR, that will appear as half into modulus of abscissa of R, that is a into sec theta minus tan theta, multiplied with the ordinate difference of Q and origin, that is b into sec theta plus tan theta, plus abscissa of Q, that is a into sec theta plus tan theta, multiplied with the ordinate difference of origin and R, that is 0 minus this ordinate, will give us b into sec theta minus tan theta, as 0 minus b into tan theta minus sec theta was the calculation, and the third abscissa for origin itself 0, which will not incur any other value into the calculation. So, we have got this as half into AB into sec square theta minus tan square theta, that's simple AB. Even from this section, it's AB into sec square theta minus tan square theta, which finally appears as AB itself, considering A and B as lengths. So, we have established that this triangle have no impact of theta in its measuring area. So, irrespective of my selection of P on the hyperbola, we will get area of this triangle constant, and that constant area is half of the transverse axis length multiplied with half of the conjugate axis length. That is, product of the semi-axis length is going to be that constant area. Moreover, as we are done with the coordinates of Q and R, you can establish from there the midpoint of QR is itself P. You can simply use the section formula or the midpoint formula to check that. Like the two abscissas, when being added, it gives you 2a sec theta, and hence the average is a sec theta. The sum of the ordinates of Q and R is 2b tan theta, and hence the average is going to be the ordinate of the point P, and this confirms the point of tangency of the considered general tangent appears as the midpoint of the side for the triangle constructed with the pair of asymptotes.